It's really important when you get a question like this that you storyboard. You look at the apparatus that's being used, and in that way you can visualize yourself carrying out the experiment. So first of all, if we look at the chemical reaction, we've got an unknown liquid which has been labelled as ZCl4, and it's being reacted with water. So we've added 1.304 grams of this ZCl4 liquid, and we add it to water, and a solid ZO2 is produced. So there's our beaker with the ZO2. So label that your ZO2. This is the solid which has got the unknown element Z in it and oxygen. So ZO2 solid in the beaker. What is the liquid that's surrounding that ZO2? It's hydrochloric acid. So let's label that as our HCl that's being produced as a result of the chemical reaction. How do we get the ZO2 away from the HCl? Well, we then carry out a filtration. So you need filter paper to get rid of the solid, and we've got a filter funnel as well. So there is our filter funnel. So we're collecting the solution, and the solution contains hydrochloric acid. And there is the unwanted solute that we don't want, and that is our ZO2. Because what are we going to do next? We're going to take this hydrochloric acid and we're going to make it up into a volumetric flask. So we pour off the filtrate, and that filtrate contains our hydrochloric acid, which we now make up to the mark with distilled water. So we've got exactly 250 centimetres cubed of the hydrochloric acid that's been made in the mixture. So we're now going to take 1/10 of that HCl, that's 25 centimetres cubed, using a pipette, and pipette that into a conical flask. So the conical flask now contains your hydrochloric acid. Inside the burette, you can see the burette contains sodium hydroxide. So your burette contains NaOH. And we know that the volume of NaOH that is being used in the titration is 21.7 centimetres cubed. We know that the concentration of the sodium hydroxide is 0.112 moles per dm cubed. So even if you couldn't do anything, immediately you can see you have a volume, you have a concentration, and therefore you know if you're given a volume and a concentration, you know that the number of moles is concentration times volume, and your volume has to be in decimeters cubed, so you must divide your volume by 1,000, because remember, concentrations of solutions are moles per decimeter cubed, and to make the units match, centimeters cubed has to be converted into decimeters cubed. So immediately you could have got a mark because you could have worked out the number of moles or the amount of sodium hydroxide. So what you need to know next is that the sodium hydroxide is being used to react with the hydrochloric acid. And because we have a standard solution of sodium hydroxide, we can now use that to find the amount or moles of hydrochloric acid, because we know that sodium hydroxide and hydrochloric acid react together in a 1-to-1 ratio to make sodium chloride and water, and the relationship is a 1-to-1 ratio. So you've just worked out the amount of sodium hydroxide needed to neutralise the hydrochloric acid that was in your conical flask. How much of the hydrochloric acid was used? Well, it was 25 centimetres cubed of hydrochloric acid. So we write down our essentials, and we know the concentration of the sodium hydroxide is 0.112 moles per dm cubed. We know the volume of the sodium hydroxide that's used from the burette is 21.7 centimetres cubed, but we need to times that by 10 to the minus 3 to get that into decimeters cubed. Then you need to tell us that the number of moles or the amount of the sodium hydroxide is concentration times volume, which is 0.112 times 21.7 times 10 to the minus 3. And we know that sodium hydroxide and hydrochloric acid react in a 1-to-1 ratio, and therefore in that conical flask here there had to be exactly the same amount or number of moles of hydrochloric acid, which is 0.112 times 21.7 times 10 to the minus 3. And we also know the volume of the hydrochloric acid that was in that flask because we pipetted it out using a 25 centimeters cube pipette. So inside that flask was 25 centimeters cubed, and we need to get that into decimeters cubed by timesing by 10 to the minus 3. So now we know the amount of hydrochloric acid that was in the 25 centimeters cubed. So if we now know the amount that was in 25 centimeters cubed, which was 0.112 times 21.7 times 10 to the minus 3 moles, it makes sense that we took a tenth out, and therefore we know we've got 10 times as many moles of the HCl in the 250 flask. So inside the 250 flask we have got 0.112 times 21.7 times 10 to the minus 3 times 10 times the amount. So now we know the amount of HCl that was produced in our chemical reaction. And if we go to our chemical reaction, we know that for every one ZCl4, we have 4 moles of HCl. So therefore it follows, if we know that the amount of HCl is 0.112 times 21.7 times 10 to the minus 3 times 10, then the amount of ZCl4 is going to be exactly the same but divided by 4 moles. So now we found our amount or moles of our ZCl4, and we also know the mass, and therefore we can now find out the MR of the ZCl4, because you know that MR is equal to the mass divided by the amount. The answer is going to come out in grams per mole. Why? Because you're dividing mass by the number of moles. So the MR comes to 214.6, and we know that there are 4 moles of chlorine for every mole of the compound. So we can now work out what 4 moles of chlorine is. So the relative atomic mass of Z, because the relative atomic mass of Z is equal to the mass of 4 chlorines, and chlorine has a relative atomic mass of 35.5, and we take that from the total MR of the compound. So the relative atomic mass of our unknown element is 72.6, and when we go to our periodic table we know it's going to be a group 4 element because it's ZCl4, and that element is germanium in group 4, just below silicon. So what you should learn from this type of question is that storyboarding is a really powerful tool, and that working to calculate the simplest one as soon as you have a concentration and as soon as you have a volume, you know you could work out the amount of the sodium hydroxide that you had present. You know that the amount of sodium hydroxide was the same as the amount of hydrochloric acid. And therefore, once you knew the amount of hydrochloric acid in 25 centimetres cubed, you times it by 100 to get it in your 250, and then you used the mole ratio. There were 4 moles of HCl to 1 mole of your ZCl4. And once you know the moles of your ZCl4, you know that the MR of a compound is simply its mass moles. Once we got the MR, you could then simply take away 4 moles of chlorine per mole of compound, which leaves you with the relative atomic mass of the element, which we could then identify as germanium.